In this lesson, we're going to be looking at how we can subtract fractions. So let's quickly review what the different parts of the fraction mean. Top number is the numerator, that's how many pieces we've got. The denominator is how many pieces would make up a whole. So 3/4 looks like this. Since subtracting fractions is quite similar to adding fractions, let's just quickly review how we add. In these fractions here, I've got one piece for this one and 6 would make a whole. And this one I've got 3 pieces and 8 would make a whole. Now the problem with adding these pieces together is they're not the same size. If I take a pizza and I cut it into 6 pieces, then those pieces are bigger than if I take the same pizza and I cut it into 8. And so what we need to do is we need to get this common denominator first. We need them the same, and the question is, what's the lowest number that 6 and 8 both go into? Because whatever that number is, that's what we've got to make them, and it's 24. So what we want to do is we want to make 6 into 24. We do that by timesing by 4. Make sure we do it to the top as well. We want to make 8 into 24, times it by the 3, and times the top by 3 as well. Now let's write down our new fractions when we do all that multiplying. See how the denominators are now the same? Now we can just add the numerators together, and the key thing is the denominator did not change. Remember, these are the number of pieces we have, 4 and 9. We don't have 24 pieces. That just tells us how many pieces would make up a whole, and that doesn't change when I put the 4 and the 9 together. 24 pieces still make up a whole, so that means the denominator isn't going to change. Now we'll also just need to simplify our answers as well, so let's make sure we remember that. If I've got 10 and 5, the question I'm asking is what is the highest number that goes into 10 and 25? And whatever number that is, we're going to divide 10 and 25 by that number. So it's 5, and if we divide 10 by 5 and 25 by 5, we end up with 2 over 5. And I know I've done it right. I know I'm in simplest form because nothing else goes into 2 and 5. If in my answer something went into both numbers still, well, I'd have to do it again. You have to keep going until nothing goes into the your answer there, the top and the bottom of your answer. But when you start with numbers here, if you're asking what is the highest number that goes into both of them and you get that right, then you'll go straight to the simplest form. So let's take a look at how we can subtract fractions, and we'll see it's a lot like adding fractions. And so here we got 5 6 take away 4 6, so I'm just going to draw up 5 6 here. So we've got 6 sections altogether, 6 pieces make up a whole, 5 of them are shaded in. Let's get rid of 4 of those shaded in ones, and what's left over is now there's only 1 shaded in. And so that means we're left with 1 out of 6 as our final answer. And this was all made very easy by the fact that these denominators are the same, so that when I was able to cross out 4 pieces, I was able to cross out the 4 pieces that were already here because these pieces were the same size as those pieces. So when the denominators are the same, just subtract the numerators. Remember, don't change the denominator. It's still 6 pieces that make up a whole in our final answer here. It's just that now we've only got 1 piece. Now let's take a look at what happens if the denominators are different. So here's 7/8 minus 3/4. So this is what 7/8 looks like. And then up here, I'm just going to put, that's what 3/4 looks like. Now, if I start trying to take away this size pieces from here, well, there's a little bit of a problem because these pieces are not the same size as those ones, and so it doesn't work. But what I can do is make these pieces the same size. If I double all of the sections there, then now these pieces will be the same size as that one because that's now got 8 sections as well, and it now turns out that 6 of them are filled in. And so that means really what I'm working out is 7/8 minus 6/8. And so now that the denominators are the same, the pieces are now the same size, I can now subtract, and I know I've got to take away actually 6 of the pieces, not 3. And so I'm left with just 1 piece left, so the answer is 1 over 8. And so when the denominators are different, we're going to find the lowest common denominator, just like we had to do when we were adding. Let's take a look at subtracting some fractions with whole numbers now, and we're going to see for the most part it works the same as with adding. We get to just treat the whole numbers separately. So here I've got 5 wholes and I'm taking away 3 wholes, so I must have 2 left over. And with the fraction part, I had 3/5 take away 1/5, so subtracting the numerators here means I've got 2/5 left over. That was pretty easy, wasn't it? So let's take a look at the next one. 8 and 1/8 take away 4 and 5/8. So let's try that again. 8 take away 4 is 4, and then wait, 1 take away 5 is 1 take away 5. We seem to have a bit of a problem here. Now, negative numbers do exist in maths, but we try and avoid them whenever possible because they can be a real pain. So we're actually going to do this a different way that avoids having to do 1 take away 5. What we're going to do is we're not going to subtract the whole numbers first. We're going to do something similar that you would have to do if you tried to do this question here. When you do subtraction here, you can't do 1 take away 5, and so you'd probably borrow from the 8. Now, there is actually another way of doing it, but most people borrow. So they borrow from the 8, they make it a 7, and they put the little 1 up there. We're going to do something similar here. What we're going to do is we're going to borrow from this 8 here. So we're going to cross it out, and we're going to make it 7. But we don't just put a 1 up here because we're not getting an extra 10 pieces. Here, when we borrow from the 8 over on this one, and we put a 1 up there because this is worth 10 times as much as this column here. That's just the way those subtractions work. But here, each whole is only worth 8 pieces, not 10 in this case. It'll be worth whatever the denominator says it's worth. And so when I cross out the 8 and I put a 7, it adds 8 to this top one in this case, not 10. It'll add whatever the denominator is. And now I'm allowed to do my subtraction normally because I'll be doing 9 take away 5 instead of 1 take away 5. So 7 take away 4, that's 3. And then I've got 9 take away 5, and my denominators are already the same. And so 9 take away 5 is 4 over 8. And from there, I can simplify this. Remember, you must always try and simplify because something goes into 4 and 8. So I can divide them both by 4, and I end up with 3.5. So the key points are subtract the whole numbers normally, and if necessary, you borrow like we did here. And make sure your answer is simplified. And just remember, the denominators need to be made the same before you do any borrowing. Otherwise, that can mess up your borrowing. So denominators the same before you start doing any subtractions or additions for that matter. Let's see some examples now. So we're going to work out 3 over 4 minus 1/6. So we start by writing out the question, and this 4 and 6 need to be changed into a common denominator. Unfortunately, 4 does not go straight into 6, and so I'm going to have to change both numbers. So what do 4 and 6 go into? What's the lowest thing? It's 12. So to turn this 4 into 12, we're going to multiply by 3. So times the top and bottom on the left by 3. To turn this 6 into 12, I must multiply by 2, so do the same to the top as well. Now let's write down our new fractions. Once we do all that timesing, I end up with 9 minus 2 as the numerators, which I can do because the denominators are now the same. So I end up with 7 over 12. Remember, of course, the denominators, the number of pieces that make up a whole, that's not changing at all. And just before we finish, quick check, does anything go into 7 and 12? No, it doesn't. That means that it's in simplest form, and I'll leave that as my final answer. And the next one, we're going to be working out 4 2/5 minus 2 3/10. So let's start by writing out the question. And before we do anything with the whole numbers, let's get the denominators the same. Now this one's a nice one because 5 goes directly into 10. And so we can just times the top and the bottom by 2, and then we'll have the denominators the same. So let's write out our new fractions. Notice that the whole numbers didn't matter when it came to the lowest common denominator. They didn't change what it had to be, and the denominator doesn't affect them. And so only change the fractions, leave the whole numbers alone when you do that. And so now I've got 4 take away 3 on top. I can do that. There's no need to borrow, so I can go straight to 4 take away 2 is 2 wholes. And then 4 take away 3 means that there'll be 1 piece left over as the numerator, and of course the denominator doesn't change. Now in our next one, again we're doing whole numbers, and again we need the common denominator, so let's write out the question. And once again, I've been nice here, I've made it a question where you can turn the 3 straight into the 15, and so we can do that by timesing by 5, and that means that we end up with 5 and 5/15 minus the 1 and 11/15. And now a quick check, 5 take away 11, that's bad, I can't do that, I'm going to have to borrow before I do anything else. So now let's cross out the 5 and change it to a 4, and I get 15 extra pieces to put on top, which means that that 5, it just became a 20. And so now I can do my 4 take away 1, which is 3, and my 20 take away 11 to go to my answer. and I've just noticed that that can be simplified because I did my quick check to see does anything go into 9 and 15 and realized it does. And so 3 goes into 9 and 15, divide them both by 3, and you end up with 3 and 3/5. Now remember, all of the green sections here, they do not need to be written down. You're encouraged to write them down if they help you remember what to do, but otherwise you don't need to worry about it. But you do need to show all your borrowing and everything you're doing there. So everything in black is shown as working you should have. Let's give it a go with some practice questions. Remember to pause the video. And there's the solutions to those. Fair bit of working to do. Remember, you don't need to have the green bits, but everything else should be clearly shown. So in the first one, started by writing out the question and look for the common denominator. 6 goes into 18, so that's nice. I just had to times that by 3, which meant I timesed the 5 by 3 as well at the top, and then I wrote out my new fractions after the timesing. Then because the denominators were the same, I could just go 15 take away 1, and I left the denominator as 18, of course, and so from there we had 14 over 18, and since 2 goes into 14 and 18, I had to divide them both by 2 to get my answer in simplest form. In the second one, once again, lowest common denominator. Unfortunately, this time 4 doesn't go into 10, so I had to multiply both numbers by something, and I turned them both into 20 because that is the smallest thing that 4 and 10 both go into. So times by 5 on this one to make it 20, times by 2 on this one to make it 20, and then wrote out my new fractions there. Notice of course, the whole numbers didn't change at all. And so once the denominators were the same, I just checked, can I do 15 take away 6? Yes, that's not a problem. So I just went 6 holes take away 2 holes is, sorry, 6 holes take away 4 holes is 2, and 15 take away 6 is 9. Does anything go into 9 and 20? No, it doesn't. So it's in simplest form. It's my final answer. Now, the last one here, I wrote it out, and I got the common denominator. 2 goes directly into 8, which is nice, so times them both by 4. And then on the next line, I noticed originally I had 4 take away 7. Now, when it came to doing my subtraction, that was going to be a problem, so clearly I would have to borrow from the 6. And when I borrowed from the 6, that gave me 8 extra pieces on top. Remember, not 10, whatever the denominator is. So it gave me 8 extra pieces for the top, and so that meant now I was doing 12 take away 7, and my holes would be 5 take away 2. So that's why there's 3 holes remaining, because that's 5 take away 2. 12 take away 7 is 5, and of course in all of this the denominator didn't change. Once you get them the same and I do my minus, it doesn't change. Here's some more practice questions. If you need to give them another go, remember to pause the video. And there we go, there's the solutions with all the working that should be shown for those. And that brings us to the end of this lesson.